Moisture management is one of the most critical factors to consider when selecting insulation systems to be incorporated into the thermal control layer of a building. Approximately 90% of all building problems are related to water. Moisture flow through the building envelope tends to follow the thermodynamic potential, moving from hot to cold, as well as from high to low concentration. In addition, airflow through the building envelope will follow the pressure gradient, moving from high to low pressure. By understanding these principles, building envelopes can be designed to effectively manage moisture. In a mixed heating-cooling environment such as Canada, wall assemblies are typically designed to dry to the exterior to help prevent rot and mold. This is accomplished through the use of a vapor-permeable air barrier building wrap system over the exterior sheathing. These systems allow water vapor to escape from inside the wall cavity while helping to prevent the infiltration of air and water into the cavity from the exterior. To achieve maximum thermal performance, today's advanced wall assemblies include a layer of continuous insulation to mitigate the effects of thermal bridging through framing members. The challenge: to provide a continuous cover of insulation without affecting the wall's ability to dry to the exterior. A common approach to achieving exterior continuous insulation on a wall is to utilize flat, rigid plastic foam insulation board products, both faced and unfaced. Although achieving their thermal objectives, these products may hinder the drying capability of the wall. This can result in moisture accumulation between the exterior sheathing and the rigid insulation, which creates an environment for degradation of the building materials and mold formation. In addition, once wet, some rigid board products may not completely dry, thus negatively impacting their R-value performance. Another method of achieving a continuous insulation cover on the exterior of walls is the use of permeable, semi-rigid insulation. These products allow the movement of moisture to the exterior and will dry over time. The challenge is that these permeable products allow moisture ingress into the insulation from both the interior and exterior. Mineral wool absorbs moisture very rapidly compared to typical plastic foam insulation, and when wet, its thermal performance will degrade. This can be a potential concern when insufficient drying time is available. In addition, the wet insulation may be subject to freezing depending on environmental conditions. So what would be the ideal solution that would provide continuous cover exterior insulation, but still allow the wall to dry to the exterior while preventing moisture ingress from the exterior? Tests performed by leading building scientists have shown that effective moisture redistribution and outward drying can be achieved in a wall assembly by providing a small gap between the sheathing and an impermeable or low permeable insulation sheathing. In addition, building science experts have also proven that Rainscreen assemblies maximize the service life of buildings by allowing walls to drain and dry, offering superior moisture management. Quik-Therm insulation has considered the challenges and benefits offered by both rigid, flat foam board and permeable mineral wool insulation products, and has engineered a third solution to achieving exterior continuous insulation without trapping or absorbing moisture. Quik-Therm Solar Dry offers the benefits of an impermeable continuous insulation board style system with an inherent drying plane that allows the wall cavity to breathe, dry, and drain. Solar Dry's rigid Type 2 EPS core is covered with impermeable polymer facers that will not allow moisture ingress from either the interior or exterior. Thus, the insulation core stays dry and retains its effective thermal performance. On the sheathing side of the system are 3/16" drying channels that occupy approximately 80% of the panel surface. Moisture trapped in the wall cavity can exit to the exterior of the building wrap into the channels and subsequently dry or drain. This helps prevent the buildup of moisture and subsequent rot and mold formation. Thermal wall assembly tests performed on Quik-Therm Solar Dry have shown that when installed as per manufacturer's instructions, the drying channels have a negligible effect on its effective R value. Thus, moisture control is achieved without sacrificing thermal performance. On the outboard side of the Solar Dry system are channels spaced either 16" or 24" on center. These channels accommodate 3/4" thick strapping, which create a 1/2" gap between Solar Dry and exterior cladding materials. The exterior polymer facers combined with a 1/2" airspace create an impermeable code-compliant Rainscreen. An interior drying plane and an exterior drainage plane, combined with impermeable polymer facers, result in moisture control on both the interior and exterior sides of the EPS core. As a result, a continuous cover of insulation can be achieved that will not compromise moisture control, will prevent the ingress of moisture from the exterior, and maintain maximum thermal performance.